students, welcome to the Gravity Lab. I want to show you the basic functions of the release mechanism, the triggering mechanism that allows us to record a certain amount of time that an object will drop, and we can do that by recording the time with our smart timer. So let's go ahead and take a look at how that can be accomplished. Alright, so first of all, what we have is we have a certain set height, and we're going to be placing a ball within this mechanism, and I'll show you how to do that in just a second. But when we release it, then what's going to happen is it's going to drop and it's going to strike a pressure pad down here. And so for that given height, we want to be able to record a certain time of fall, which we can do with our smart timer that was introduced to us previously. So let's go ahead and see how we can get all of that integrated together with one another. So first off, setting the height. Well, what we need to do is we need to get the ball inside the mechanism. So what we have here is we have a leaf and we have a spring, and what we want to do is we want to hold back on that spring and we want to tighten down with the set screw. There's a set screw right there, and if you've done everything correctly, the ball has contact with the leaf spring, and so the height that's involved here is measuring with a meter stick from the base of the ball to the pressure pad itself. So once you have that set, then what we can look at is the amount of time it takes for the ball to fall. So that's where the smart timer comes in. So let's revisit that and take a look at its functions. So as before, we have to turn it on, and we're looking for a time. So with button number 1, we set that to time, and we have to select our mode. That's the blue button. And in this case, we're going to be using the stopwatch function. Right. Now what's important here is before you hit the start-stop button to engage the smart timer, as we've seen before, an asterisk will show up. We need to have the ball placed in the spring at the top, right? So that now you won't accidentally trigger the time. So you place the ball in first, and then you engage the timer. And so if all goes well, what should happen is, as I release the ball, and we want to make sure with some practice runs that you're actually striking the center of the pad that's at the bottom. Let's see if we can notice that. So I'm going to loosen the screw. So I'm going to loosen this screw, and we're going to let the ball fall and see if we actually get a reading, and also notice if what we're trying to do is hit the center of the pad. And it looks like we've struck pretty well on the pad at the bottom. And then we come over to the smart timer, and we notice that we indeed have a time that's quite precise. 0.4548, roughly about half a second. And the time that you get ought to make sense. You know, obviously if you get something like 20 seconds, that's way outside realistic time. So the times will be on that order, and what you're going to be doing is you're going to be setting the heights to different values, much higher, some shorter, and by so doing, recording the times. And so what we're looking to do is see how height versus time relate to one another. And so not only are you going to do that with the sphere that we inserted, but we're also, that's the one that I'm holding in this hand, we're also going to be doing it with a smaller sphere. So we'll not only notice for a given size sphere how height and time relate to one another in a specific way. We're looking for a certain power that does that formula-wise. We're also going to go through the experiment again, but with a smaller sphere. So of a different mass. They're similar shape, but different mass. So in this way we can investigate the role that mass plays